So I consider myself pretty green in this, but I was drawn to it, especially since Desimone formally set up an R&D group this year, actually. So what's my motivation for getting involved in basically ACI 131 and looking at IFC is kind of curious what's over what I call the production fence in terms of what the people on the BIM side of the company are doing and how we can use that on the the nuts and bolts day-to-day engineering side. And how can we streamline our production using these established standards such as IFC. A couple days ago I was on Building Smart's website and they said IFC is the PDF of BIM, which I thought was, now that really talks to me, that makes sense, right? And so is there something in IFC that can help support basically our structural analysis, the structural design to BIM? So the stuff I'm concerned about doesn't actually leave our office, whereas I think a lot of the other BIM value is communicating a bunch across all the stakeholders. So this is my abstract version 1 from April 2023 when I was all excited and we knew we were going to have a session and said, you want to present? And I said, yes, I'd love to present. And as you can see, all the strike-throughs on my abstracts, mostly based on it's been impossible to find personnel to hire that have domain expertise in structural analysis, as well as a software development experience, not coders, but people that actually know how to write software. And so this is the version 2, which has been kind of dialed down a little bit, and I call it more musings because I'm not going to sit here and tell you we've done all these wonderful things since April, which I hoped I would have been at, but we're not. But so what I'm going to do is I'm going to kind of describe to you the column design workflow at Desimone right now, and I've worked at KPFF and MKA, and it's pretty much the same stuff. Might be different program names, but pretty much it's the same process. And I think that'll help you appreciate, or maybe you can see how IFC could help kind of streamline that process. And then I'm going to talk about kind of describing our current workflow, and we're going to identify some major shortcomings. What would a future workflow look like? And then how could we plug in the EM6 and EM15 into that workflow, talking about how we could do it, and then just some summary and conclusions. So this is our current design process. And where's the laser pointer? Is it coming up? There it is. So, our current process, like most firms, is you get your design loads. We use primarily CSI applications, ETABS, and SAFE. And so in ETABS, you might do a 50-story stack, 50-story model, and you might use the gravity loads in the columns if you model it correctly to get axial loads in the columns, or you can stack single floor models up to height of the building to get your column axial loads. And so for conventional slabs, we use SAFE, and from Bentley, we use RAM Concept for PT slabs. And then from there, we go to flat files from Bentley. They do have a Python API, which we will be exploiting in the future. And then CSI will basically, you can export access database files. And pointing out that, important to note that the schema for these files can change from version to version. So you're always having to go back and tweak your code to actually get the loads out. And then we have a custom app right now that's called CLTD, Column Load Takedown. And what that does is it kind of stacks everything up, and it runs SP column, designs the columns, and then the engineer will do the classic, print out the PDF of the column schedule and mark it up and send it back to the drafter in Bluebeam, or like I'm old school, so I just use a red pen, scan it, and then all of a sudden you're in the BIM model, and you're done. But that's kind of, you're not going back. It's basically, I like to point out, it's a one-way trip. So the big problem with this approach is the issue related to vendor lock-in, which is, we're relying on the export format from, ETABS or SAFE for Bentley's products. And the solution that we've come up with is that basically a centralized data repository with a standard interface, which we call the DCE data bus. So I like the analogy of a computer bus, right? It's just basically you put everything on the bus, and anybody can talk to it or grab from it. And it's kind of like, if you're familiar with software as a service, it's kind of like data as a service. So this is the future workflow, and the reason I'm going to show you where we envision our first foray into IFC, where it might fit in, is we have a couple of things to point out. Is this dotted line here is the boundary between internally developed software versus external products, which are over here. And this line right here delineates cloud stuff from in-house stuff. So over here we have our third-party apps, and almost every app nowadays has some sort of API. And so instead of having our custom engineering apps talking directly to these apps, basically we're going to have basically a little converter app that talks to the various APIs and basically plugs it into the Desimone database, which is on the cloud. We're on Azure now. It's basically storing all the fine element results on Azure in a standardized format, because various programs have different local axes definitions for columns, and different sign conventions for internal forces. And so what we envision is that if we can get the column design in here, we can use basically IFC to pump it into Revit instead of basically marking up the PDFs like we used to do. So that's kind of a description of a potential use of IFC in a column design workflow. Sounds like Leonardo's already figured out a lot of this stuff, but this is kind of our first pass. And so first thing is, how can we use EM6? And as Leonardo described, basically for column design, basically longitudinal bars, stirrup size, spacing, and layouts. And then there's a potential to use EM15, and I'll show you an example later of why we might want to do that, and basically shows all reinforcement. We wouldn't do it for an entire building, but there might be cases if you have congestion issues, you can look at it. And just to kind of highlight how currently the 131 and most documents are focused about, the structural engineering firm is making a product for somebody else. The stuff I'm concerned about is, I guess, internal customers inside the company. And so here's so a lot of this stuff I think Leonardo described well, but basically the data we only need for internal workflow is right here. Column size, stirrup layout, vertical ball, longitudinal reinforcement, and ties at the ends and the middle. This is a seismic gravity column, so it's uniform over the whole height. EM15, now my experience has been on the West Coast, so we've got a lot of situations like this, and it would be nice to be able to basically render just a very small portion of the building in-house easily. And since we're already writing tools that like we have tools that design diagonally reinforced coupling beams, and we know the development lengths, and we know the angles, the number of bars and stirrups. So we could take that information and basically generate an IFC in the EM15 format to basically visualize it in Revit. And so here's a more extreme case. And then next page I'm going to show you is basically a view of this corner. This is something we did in-house, but the BIM people had to do this by hand. We didn't have an IFC file just to crank this out. So it took quite a while. I forget the number, but basically this is the kind of stuff that we would like to be able to do on a kind of on an as-needed basis for congested regions. We're not trying to detail the whole building, so I can see another use for IFC to do that. So we're already writing our own software to do the analysis. Let's just generate the IFC so you can actually view it. And so, yeah, it's a short presentation because I'm sure others are going to go long, but basically, concluding remarks and summary, the work has just begun on our DCE data bus. We have a SQL database guy who's working on the schema for that with us. And to start, EM6 does have the potential to be used in internal workflows. And then basically the design will be stored in the DCE data bus and converted to IFC for import to Revit with all the appropriate information that can then be exported to external clients would already be in the model. And then EM10 can be used potentially for engineers in the office to kind of like an engineer can say, I want to see if this is going to be a complete disaster in terms of rebar layout. And so they could actually, most engineers now are pretty savvy with Revit, so they wouldn't even have to bother a BIM developer. They could just do it at their desk pretty quickly. And something that I thought about last night was, you know, since we're working with SQL databases and IFC is basically an object tree structure, it seems like you could store the IFC in a relational database, and of course, if you Google that, you come up with IFC SQL, and that can also be leveraged to store the IFC directly in a database instead of generating on the fly. And so that was my short kind of summary, and I guess we're doing questions at the end.